Hi all, here we are on day 3 of Systems of Equations. We're going to be talking about the method for solving that's called elimination. As you can guess, we're going to be eliminating some stuff. As always, this is a production of Conalonzo Inc. We want to share our math with you and help you learn. Our goals for today are going to be to determine if or how a system of lines intersects. We also want to be able to solve a system using the method called elimination. And we're going to walk through that and what that looks like. So the method of elimination, as you can guess, eliminates a variable. And what you want to do is have the same coefficient so the variables can either add or subtract to make 0. So if I'm looking at this system here, I've got two lines. Both of them have a y, a 1y. One is plus y, one is minus y. So I know if I add these together, I'm going to get y plus negative y, which is going to be 0, and those are going to eliminate. Amazing how that works out, right? So then I can just add all the other pieces and I can get an equation that I can solve. So if I add 4x plus x, I get 5x. If I add 11 plus negative 1, I get 10. I can divide by 5 and I can get x equals 2. Now that was a little less intensive than the substitution method, and it works out great here because my y's are the same. Okay, not always set up to do this, but in this case, my y's are the same and they cancel out really nicely. Remember, we talked about this earlier, I'm not just finding x, I'm solving for the point where these two lines intersect, which means I need a y coordinate of that point. I'm going to take the 2 and I'm going to plug it back into one of the equations, and it doesn't matter on this system. And then I'm going to check in the other equation, okay? So I like to kind of follow the same process every time. So I usually plug into the top equation and then I check in the bottom equation. So I'm going to take this 2 and I'm going to put it into the top equation for x, and I'm going to figure out what y equals. Notice this is a little bit like what we were doing yesterday when we were substituting back in to figure out the second variable. It's the same idea, okay? So 4 times 2 is 8. And then I'm going to subtract the 8 and I'm going to get y equals 3. So 3 is my y coordinate. I want to make sure, so I'm going to check this in the second equation. I'm going to take x, which is 2, minus y, which is 3, and I should get negative 1, which I do, so that checks. 2, 3 is the point of intersection for these lines. So with elimination, again, we're just trying to eliminate a variable by either adding or subtracting. You can do either one in order to eliminate the variable, okay? And a lot of times people ask the question, okay, how do you know whether you should add or subtract? And here's my little helpful hint, if you will. Same signs, subtract, okay? Different signs means that you add. Same signs, subtract is pretty easy because of the alliteration there with the letters. Different signs means you add is just kind of remember the other way, okay? So here my y's were different signs, which is why I added them together. Looking at this next one here, they're again the same or different signs, so I'm going to be adding to get my y's to eliminate because y plus negative y is 0, which then means that I add all the other pieces. So I'm going to add 2x plus x to get 3x. I'm going to add 5 plus 1 to get 6, and then I'm going to solve, and I get x equals 2. That's not my solution. That's just part of it. I need to go back and find my y coordinate. So I'm going to put 2 into my top equation, and I'm going to solve for y. Now, again, I don't really have like a mathematical reason. I just like to follow the same process so I don't forget things. So I always plug in the top and check in the bottom. It's just an easy way for me to remember which equation I put into, okay? And part of that is when we get into more difficult systems, sometimes it's hard to remember which one you plugged into because you're doing a lot of work on a paper, and I can't talk and write at the same time clearly. I'm subtracting 4 here, which is 1. And if you don't have a process to follow, sometimes you plug it into an equation and then check it in the same equation and it doesn't work. So, or it's not right because you didn't check it in the second equation. So make sure that you're plugging in one, checking in the other. So I plugged in the top and I got y equals 1. Now I'm going to check this in the bottom equation. So I'm going to take x, which is 2, minus 1, which is y, and I should get 1. 2 minus 1 is 1. There we go. So 2, 1 is my point of intersection for these two lines. Let's look at this one here. Now, I don't have any variables that are the same. I have an x and 3x, or I have a 2y and 4y, which means that I need to somehow get them to be the same, which means I'm going to be multiplying an equation. It does not matter which variable you do as long as you get one of them to be the same. So I'm looking at the top equation. I'm just going to multiply this by 3 because then I'll have a 3x, okay? And what you do to one thing, you have to do to the whole equation. So I'm also going to multiply the negative 2y and the 1 by 3. And when I do that, I'm going to write that underneath just to make sure that my variables line up really nicely. So 3 times x is 3x, 3 times negative 2y is negative 6y, and 3 times 1 is 3. Now I have two variables that are the same. They also have the same signs, so I will subtract because 3x minus 3x is what makes 0, which means I'm subtracting everything else. Be really careful about your signs, okay? On this second part, I'm taking a negative 4y minus a negative 6y, which gives me a positive 2y. Again, if you're not great with negatives, use your calculator. It's no big deal. There's no shame in using a calculator to make sure that your answer's right, okay? So take negative 4 minus negative 6, and you should get positive 2. And then I'm going to take 11 minus 3, which is going to be 8. I'm going to divide and get y equals 4. Now remember that this is my coordinate, and I need to go back, or my y coordinate, and I need to go back and find my x as well. I like to always plug in the top and check in the bottom. So I'm going to go back to my very top equation. I'm not going to plug into the one that I multiplied. I'm going to plug into my top equation, my original, and I'm going to put 4 in for y, and I'm going to see what I get for x, okay? My reason for doing this is just in case I made a silly mistake when I was multiplying. I don't want to then put my answer back into that multiplied one and make another silly mistake. So this will help me catch if I made a mistake and also make sure that I'm doing it correctly, okay? So 2 times 4 is 8. I'm going to add 8. I'm going to get x equals 9. Now remember I plugged in the top, so I want to check in the bottom. So I'm going to go to this second equation here, and I'm going to plug in 9 for x. I'm going to plug in 4 for y, and I'm going to see if I get 11. 27 minus 16 does in fact equal 11, so I am good with my solution. Again, just kind of follow the process. If your variables aren't the same, you're going to want to multiply to make them be the same. It also is really important that you line up your variables, okay? So look at this one. My y's and x's in the top equation are messed up. So I'm going to just rewrite this underneath in the correct order. I'm going to have negative 2x plus 3y equals 6. And look, once I put them in order, now my x's are the same, and this is going to be very easy to eliminate. They have different signs, so I'm going to add because 2 plus negative 2x is 0. Y plus 3y is 4y, and 10 plus 6 is 16. When I divide by 4, I get y equals 4. So sometimes it's just a matter of rewriting, making sure that your variables line up and are in the correct order, and then you can solve pretty easily, okay? Now I'm going to substitute back into the top, and again, I'm going to go to my very original equation just to make sure I didn't do anything silly with my signs when I was moving stuff around, and I'm going to solve. So 3 times 4 is 12. I'm going to subtract 12 from 6, which is negative 6. And then I'm going to divide by negative 2, and I get x equals 3. So 3 is my value for x. I want to check these in the second equation just to make sure. I'm going to take 2 times x, which is 3, plus y times, just y, which is 4. And then that should equal 10. 2 times 3 is 6, plus 4 does in fact equal 10, so that checks. So my answer is 3, 4. The point where these two lines intersect would be at the point 3, 4. So we kind of are manipulating some equations here, whether we're moving stuff around or we are multiplying to get our coefficients to be the same. Remember, we can add or we can subtract to try to get the correct or the variables to eliminate. That's the whole goal, of course. And so we want to just kind of play with these equations a little bit. And there's two methods here. We talked about substitution, we've talked about elimination. Most of the time, it's going to be your choice as to which one you prefer to use. Let's look at this one here. This one's a little more difficult because none of my variables are the same. And it's not like I can just multiply 2 by something to get 7. Those aren't even in the right order. Or 5 by something to get 3. So I'm going to end up multiplying both equations by something, make them the same. And again, it doesn't matter what you do. So just pick a variable and go with it. Okay, I'm going to pick x. So I have a 2x and I have a 7x. What do I multiply them by to make them the same? Clearly, I'm going to multiply the 2 by 7, and I'm going to multiply the 7 by 2 in order to get them to both be 14. Now, while I do this on the top equation, I'm also going to write it in the correct order so that my variables line up, because that's going to make this whole thing a lot easier, okay? So notice I multiplied 2x times 7, and I wrote that first. I multiplied 5y times 7, and I wrote that second. And now I'm going to multiply 14 by 7, and that's going to go over here. Don't forget to multiply that last number by whatever you're multiplying the equation by, okay? Then I'm going to do the same thing on the bottom equation. So I'm going to multiply 2 times 7x. I'm going to multiply 2 times negative 3y. And then I'm going to multiply 2 by 8. Now I have my variables lined up. I have my coefficients of x the same. I can subtract them because they have the same sign. And I get 14 minus 14 is 0. Then I'm going to subtract everything else. So 35 minus negative 6 is 41y. And 98 minus 16 is 82. I'm going to divide 82 by 41 and I get 2. So the y coordinate of my point that I'm looking for is 2. Now I'm going to plug that into my top original equation. So I'm going to go back here and I'm going to plug that in for y and solve for x. So I'm going to take 5 times 2 plus 2x equals 14, and I'm going to solve that. So I'm going to multiply, I'm going to subtract 10, and I'm going to divide by 2, which gives me an x value of 2. Remember, I always want to check this. So I am actually going to check this in the bottom equation, the 7x minus 3y, etc. So x is 2, y is 2, 7 times 2 is 14, 3 times 2 is 6, and 14 minus 6 is 8. So this is my solution. 2, 2 would be the point where these two lines cross. So I hope this is making sense for you. Again, you have two methods for solving algebraically, whether it's substitution or elimination. And you can kind of determine which one's set up better by how you're given the problem and then go from there, okay? Remember, substitution, you're substituting. Elimination, you're trying to eliminate the variables by getting their coefficients to be the same and then adding or subtracting based on their signs. As always, if you have any questions, let us know. We're more than happy to help. And we hope that you're doing great, staying healthy, staying well, and understanding math. Have a fantastic day.